Hello, everybody, and welcome to this Engineering Excellence Talk. I hope you are enjoying the program so far. Before we begin, please let me share some quick information. This session is being recorded and it will last 55 minutes. Today's agenda features a speech from our guest and a Q&A session at the end. If you have any questions, please feel free to put them in the chat. It is with great pleasure that I introduce our speaker, Udi Dahan, who is going to talk to us about different perspectives on the practice of software architecture. Udi Dahan is one of the world's leading experts on software service-oriented architecture and domain-driven design. He is also the creator of NServiceBus, especially known for the .NET developers, as it is the most popular service bus for .NET. Ladies and gentlemen, please join me in welcoming Udi Dahan. Hello, Udi, and welcome to the EngX Community Day.
Hi, Marta. Thanks so much for having me. It's a pleasure to be here. Some of you might remember me because I gave a presentation, it must have been 3 or 4 years ago, maybe even more, at the EPAM event that was, I think it was in Bulgaria at the time. So my guess is that some of you have seen me before, whether it's in the EPAM conference or online or at the various other conferences that I present about. Today I'm going to be speaking about the different perspectives on the practice of software architecture. First of all, before we get started and dive directly into the material, consider this a fair warning, right? Some of you know me, know that I kind of say things that some of you might not agree with, things that might sound a little outlandish or weird or different or counter to the orthodoxy of software architecture from various places. But as stated in that well-known movie, all I'm offering is the truth, nothing more. So, a lot of what we do is really, going down that rabbit hole of Wonderland. And things kind of get a little different and weird in terms of how things kind of fit together. And at times, let me warn you, it's not going to be pretty. There are going to be all sorts of things that you're going to look at them and say, that's kind of weird. I'm not sure I like that. I'd like to kind of go back inside the matrix and how things were before, where everything kind of made sense and gravity was real and there was friction and all those kinds of things. So seeing as I have you as a captive audience and I've put these caveats up front and warned you properly, let's dive into it. So topic of software architecture has been debated for decades, really. But even to this day, not everybody agrees as to what it actually is. Same thing can be said about software engineering. As a field, we're kind of young and still figuring out what things are. So a lot of times when people say software architecture, they're referring to something that might look like this, some sort of layered architecture that has a presentation layer across the top and data accesses along the bottom. The interesting thing about the software architecture is that kind of any way you kind of go about it with regards to layers is that we kind of draw a bunch of layers, and then there are these things along the side. We call them cross-cutting concerns. They're not layers, but we kind of know that not everything is going to fit into a layer. So we're like, okay, we're going to do layered architecture. Our software architecture is layered, except for the parts that aren't. And it isn't always clear why a certain part should be in a layer versus not in a layer. Other times when people refer to software architecture, they draw diagrams like this, big old entity relationship diagram specifying all the entities and all the attributes that are on all of those entities and the relationships between them, one to many, many to many, one to one, those types of things, whether that's stored in a relational database or nowadays as we use NoSQL databases. A lot of times the way that people still reason about the system is based on the entities that make them up and the relationships between them. So we've got layered architecture, you could call that an entity architecture form of software architecture. database architecture. There are other pictures that are sometimes used. This is the use case view that takes sort of a user-centric approach of saying, well, what are the actions that a user can take from the start? So you got logging in and logging out, and then all the other things that are sort of available from that, and some use cases that you can only trigger from some previous use case. And when you've got multiple actors, you've got sort of the end user, and then you've got the support staff, and then you've got administrators, and all these people need to be able to interact with that same system. And for us to be able to understand what are the relationships between those use cases. And, you know, it seems like round and round we go, and each time it's a, yeah, we sometimes need that picture, and sometimes need this other picture, and kind of swap between them. We usually don't have a really good mapping between these different pictures. And, you know, we're not really that good at keeping any of them updated, to be honest. So when talking to people and saying, well, what's your software architecture? Somebody's like, well, let me check my emails. I think I might have a PowerPoint presentation from 3 years ago. But any relationship between that and what the system actually does and how it works today is almost random at that point. So even if we had all of those things together and we had some way to keep them up to date, and we had some way of linking them to each other and navigating them, you know, and that's a very far path from where any of the practice of software architecture is today. Unfortunately, a lot of the times when people with software architect titles are trying to communicate, whether it's with developers or business stakeholders or anything, these pictures don't really help that much, unfortunately. So now, for those of you who know me, you know most of my presentations start off by talking about the things that are not working well, the problems with it. Bear with me as we go along. I'll start talking about some solutions and how to move towards them. But first thing to notice is that, you know, on the one hand, when we look at, let's call it programming, software programming is really much grounded in precision. You know, programmers, developers, engineers know we need to be precise. When you're talking to a computer, the computer will do exactly what you tell it to do. You don't always know what you intended for it to do, but it will do what you told it. So whether it's programming languages that have, you know, all sorts of very specific keywords and data structures, and programmers go on and talk about the differences between when you should use a class in a struct and int 32 versus an int 64, and decimals and date times versus date time UTCs, being very careful about checking for nulls and how many times a loop will run. A lot of what we do about programming is really that sort of precision engineering and making sure all the pieces fit together in just the right way. And, you know, for those of us that are doing test-driven development, we make sure that, you know, we're writing the test first and we're specific with the tests that we've got, and we make sure that we write a test for every single edge case. And then when we start talking about software design or software architecture, it seems like we go from this really sort of micrometer level, super duper precision engineering to a Jackson Pollock. It's just pictures. And sometimes, you know, there's kind of this sense of, are you sure you're holding it up the right way? Maybe it's supposed to kind of be the other way up. So it's kind of weird, this dissonance that we've got between the practice of programming and the practice of software design and architecture. So, I mean, in this day and age where everybody's doing microservices or talking about doing microservices, the interesting thing is that if two developers are saying, yeah, we should have a microservice for that, it isn't always clear, well, what do we mean by that from a design perspective? When we say we should have a microservice for that, does that mean it gets its own database, or will that microservice be using the same database as the other microservices? Not defined. So we're saying, okay, we're going to have a separate microservice. Are we going to use the command query responsibility segregation pattern for it? Is it going to be a CQRS microservice or not? Is it going to have a separate read model? What kind of database should we be using for that? SQL, NoSQL? What about the domain model? Are we going to be using the same domain model as other microservices are using, or will it have its own domain model? Will that be an event source domain model or not? Like so many attributes of design that could apply when making a decision about how to design a thing. But a lot of times those you kind of skirt through those and say, yeah, everybody knows what we mean when we say microservice or entity service or process manager or really any type of term in the field of design and architecture. Just as a quick note, because I mentioned domain models, and this is something that um I keep seeing this problem over and over again about that domain model pattern. And a lot of times people use that and say, oh, yeah, we should have a domain model. Domain models are good. We're doing domain-driven design. We've got to have a domain model, and that's part of our ubiquitous language, and we use these terms a lot. Be really careful about having one big domain model that is meant to cover everything. And as they say of the One Ring, and in the darkness bind them, because that's what tends to happen when you create sort of a centralized domain model that is meant to handle essentially all of the logic of your system. I got to tell you, it looks like a good idea when you start with it, when you have 5 entities, 10, 15 entities. You're like, oh, okay, yeah, this is kind of okay, sort of working. But 2 years into the project, where you've got 75 entities, and it isn't clear exactly which of those is an aggregate versus an aggregate root, and how you navigate between them, and where the transactions are, what is being used for reads versus what is being used for writes. The complexity, it just explodes out exponentially. So in presentation after presentation, I feel the need to repeat the book that actually defined the domain model pattern. This is from the Patterns of Enterprise Application Architecture book, written, I think, probably 20 years ago at this point, close to, by Martin Fowler and others. The definition of the domain model pattern talks that it's an object model of the domain, incorporates both behavior and data, and people are like, hey, yeah, we know that bit. Here's the important part. You're supposed to use this when you have complicated and ever-changing business rules. All right? And people saying, yeah, of course, we got a complex system. We got lots of rules that can change. That's why we're using the domain model pattern. In the book, it makes it clear, if this is taken verbatim from page 119 of that book, if you have simple not null checks and a couple of sums to calculate, a transaction script is a better bet. Now, for those of you who have a domain model, I would like you to, honestly go and check how many not null checks are in that domain model code. My guess is you've got them all over the place. Indication that you're kind of using the domain model for something it wasn't really designed for. And there are any number of other patterns. There's transaction script, there's active record, there's the domain model pattern. And most importantly, as I was saying before, there's no requirement to say you can have only one domain model in your system. It's just an object model of the domain. A number of years after this book came out, there was another book, the Blue Book, the Domain-Driven Design book by Eric Evans, who talked about subdomains. So you don't just have one big monolithic domain, the domain is subdivided into these subdomains. And that would mean that you would then have, if you are using a domain model pattern, different subdomains would have different domain models of their own. So if you're doing anything of size or of any complexity, chances are very good, 90% plus, you've got more than one subdomain, which means you're going to need to have more than one domain model. So be aware, not just one domain model. And even when you have a domain model, don't use it for everything. It's meant to handle only the complicated and ever-changing parts. So things that always get talked about in various, demo-y type of presentations saying, well, how do we guarantee that a user's username is unique when they sign up? Is that a complicated and ever-changing business rule? My guess is no. It's quite a common and simple business rule that doesn't really change at all, ever. That's why we're talking about it 20, 30 years on in all of the various types of systems. Ergo, if it's not a very complicated and ever-changing business rule, you don't need a domain model pattern in order to implement that functionality. So, just as a baseline, not everything goes into a domain model, and you should have probably more than one of them, one for each subdomain. So let's talk some more about this design and architecture type of thing. So even beyond the domain model and sort of the inside parts, back to sort of the design and architecture, we talk about all sorts of things. Said, well, we've got to have Kubernetes. Why? Well, because everybody else is doing Kubernetes and we need to have it on a resume, right? This is just resume-driven development. Need to have Kubernetes. Does anybody know why? Usually not. It's well, we can scale it that way, or it's going to be more portable between clouds or whatever. So just as a quick note on the whole Kubernetes thing, there's nothing specific to Kubernetes that is the thing that is going to make your code or your system scale when it wasn't scaling before. But so many questions still don't get well addressed of the for a given microservice, a given unit of thing that you've got. It's the how's it communicating with the other things? If it's a synchronous type of request response communication, then if you scale one of them, then you're going to have to scale all of the rest of them. And if they're all going to be scaling up and down together, then why have it in its own Kubernetes pod? So in my experience, if you start asking all of these questions as people are doing their design and architecture stuff, a lot of them will say, stop asking so many questions. We know what we're doing. Let's just get on with it. And the sad part is that almost for any term that you pick in the field of design and architecture, really nobody knows which way is up. So let's take some other terms that you've probably seen and heard before. So for example, event. So saying we should have an event-driven architecture. Does that mean that everything is going to be done with events? Does that mean when the user logs into the system, you're going to implement that with an event? No, that's kind of silly. So not everything is going to be an event. So how do you define what is an event versus not an event? The whole element we talked about, microservices or domains or DDD or domain models. Publish subscribe is sort of another one related to events. When people talk about PubSub, they're not always specific of saying, what is the type of thing that we're publishing? Is this essentially we're doing data distribution and trying to keep lots of replicas of the same thing in sync? Or is this more of a logical event that we're passing? How much data should even be in an event? When we say that we want our services, systems, microservices to be loosely coupled, does that mean that we put lots of data in the events? Because that way the recipient won't have to query for additional things afterwards? Or does that mean that we put very little data in the event so that we minimize the amount of coupling to the event schema? So even when we use terms like loosely coupled at an industry level, at a company level even, I got to tell you, so many companies I've been at, you talk to two different developers, they'll have different interpretations of what loosely coupled is, whether that's at the design level or at the code level or at the architecture level. So again, as an industry with all of this stuff going on, it's kind of funny. We don't even agree on what the terms mean. So if you'll bear with me a second, I'm going to go meta for just a second. You've probably heard I've mentioned the term the ubiquitous language with regards to domain-driven design, saying how important it is that between us, the technical folks, and our business stakeholders and our users, we develop a ubiquitous language, meaning a language that we all understand and that the terms are clearly defined and understood the same way by everybody that's involved. And yet what we're seeing here is that amongst ourselves, we don't have a ubiquitous language of design. We don't have a clearly defined definition of event or microservice or loosely coupled or pub sub or any of those things. And then, is it any wonder that we end up in trouble? And that's even with the same people working together. It gets that much harder where you've got sort of people that are cycling in and out of projects, or the bigger the project is, or the longer that it runs for, then the more the likelihood that somebody's going to leave midway through. You're going to get somebody else that's coming in. It's the graphic here that's saying, what are they talking about? That's actually the good case, that somebody's able to notice and kind of say, I think we're talking about different things. The worrying part is where people assume they know what each other means. That, oh yeah, totally. He said microservice, I'll go build a microservice, but it ends up being a totally different thing than the other person intended. So it's that false certainty in the shared understanding of what these terms mean and how to go about building them that gets us into so much trouble. Now, imagine for a second another field. Medicine, for example, was like that. Imagine if terms like diagnosis didn't mean the same thing to different doctors. That when one doctor uses the term diagnosis, they mean it like the commonly used definition of a assessment of what's wrong with the patient. Whereas another doctor assumed that the word diagnosis actually means disease. So imagine these two doctors trying to talk to each other. One of them saying, "So, did you give the patient the diagnosis?" Another doctor saying, "What do you mean, give the patient a diagnosis? I'm not going to give the patient diagnosis, because for them that means giving the patient a disease." Medicine would just not work. We'd be in the dark ages. When one doctor says scalpel, everybody should understand scalpel the same way. Now, to be clear, I'm not saying that the field of medicine is perfect and that mistakes aren't made, but they've come up with a whole bunch of processes and practices to compensate for the human failures that occur, even when there is agreement on what terms mean. So for example, if you're going in for knee surgery, they might use a marker and put on, operate on this knee, don't operate on that one. If you've ever been under a medical procedure, you'll have 3 different doctors that are asking you 3 different times, revalidating this is the condition, that is your name. We want to make sure we're operating on the right patient, checking not just your name, but let's say your social security number, and verifying that yes, this is the right thing that we're dealing with, that it's the thing on the right side and not on the left side. So as the software industry, we haven't even recognized that we have this problem yet. Although we're making a lot of mistakes along the way, a lot of the time it's like, yeah, the project didn't go so well. We'll try better next time. But, one of the core parts that drove medicine to get to the level of maturity that it's at today is that idea of what they call the post-mortem, a blameless post-mortem, where they looked back and said, when something bad happened, post-mortem means literally after death. So after something bad happened, let's reflect on it and figure out what went wrong without associating blame, and try to update our processes and practices so that we don't make that same mistake again. In software, we've got retrospectives, but I got to tell you, as a consultant, I've been to countless organizations where they go through the retrospective, and then at the end, they're like, okay, this went well, that went poorly. And I'm like, oh, and? They're like, what do you mean, and? That's it. That went well, that went poorly. Now we go do another Scrum iteration, whatever type of thing. Well, are you going to change anything? I mean, the purpose of doing a retrospective was to learn something so that you could do better the next time. That involves changing things. If you never change anything as a result of a retrospective, it's kind of pointless. And when talking to those people, they're like, yeah, well, in this organization, we're not allowed to change things. We don't have that power. We tried changing things once, and the managers got mad and changed them back. Like, well, so to be clear, I'm not saying that all of this is the fault of software practitioners. Managers are just as culpable as everybody else in what's going on. But it's important to understand, as an industry, as organizations, we need to start taking a more mature approach to these types of things. Now, to be clear, we've tried solving these problems once before as an industry, and it's gotten a lot better than it used to be 20, 30 years ago. So back in the day, a bunch of practitioners got together and started saying, you know what, let's start defining our terms. And the first patterns book was created, the Pattern-Oriented Software Architecture book, POSA, it was called, Volume 1. Now that was published back in 1996. So, just about 25, 26 years ago, which in internet years is like an ice age ago or something, ancient history. And unfortunately, many developers these days, they don't read materials that old. But since then, more and more books came out that said, you know what, we need to name these patterns. We need to be specific in what these terms mean so that we can talk to each other, so that when we say terms, we can know what each of us mean. So roughly 20 years ago, all of this stuff came out. And that idea of being specific and precise, not only in the practice of programming, but also in the practices of software architecture, we decided we need to do that. And then just time went by, and then we got a whole lot more technical people joining our field as the computer industry boomed. And the folks that were around and remembered those things, they're maybe 1% of the industry now. And everybody talks about how things move so fast, but we're just making the same mistakes and problems over and over again. We just can't keep up with the growth of the industry. So while this presentation is not to say that we all should be solving the problem at the level of the whole industry, I got to tell you, for a given project, for a given team, it should be possible to improve these things. So you don't need agreement between everybody on Earth, but you should be able to come to an agreement with the other members of your project to say, when we say database, this is what we mean. When we say entity, this is what we mean. When we say read model, this is what we mean. When we say event, this is what we mean. And start creating that type of dictionary and have everybody buy into, yep, that's what we mean. Gradually over time, create more architectural documentation, a dictionary of terms. And as you have that, maybe start sharing that with other teams that you're working with. It'll take some time, but it's better than the alternative of these misunderstandings. So now sometimes people ask, well, where would we even document those things? They try to keep it as close to your software artifacts as possible. For those of you that are using GitHub, try using a markdown file. Put that in one of your code repositories. Create an architecture repository. You might have heard about architecture decision records as a pattern. Put these architectural definitions in that same place. When you're using a term, try linking to that definition. Gradually over time, start getting more diligent in the practice of defining your terms, linking to the definitions, and hopefully over time, you'll be able to take just that mess of rope of all sorts of things that you've been hanging yourself with and gradually, bit by bit, kind of make a little bit of order in one team and then do another cycle, get a little bit of order to your adjacent teams. And hopefully from that, with the maintenance folks and the support folks and some of your business stakeholders, and over again, you can get to that point where you now have the building blocks to start talking about these different dimensions of architecture and what the building blocks are and how they relate to each other and what they mean for this system and what they mean for that system. But, just be aware that even as you're doing that, unfortunately, there's just a whole lot of cruft in the systems that you got. When you look at a system from the inside, sometimes you can sort of tell it's like, oh, yeah, there was an intention that there was kind of like an up-down layering at some point, and there's kind of a side-to-side, left side versus right side type of difference. But sort of the, how does it actually work today? You sort of pull at a thread and see where that takes you. So I want to talk about some of the management sides of why these things occur. As I mentioned, there's work for us to do on the software developer, architect, practitioner side to get things better. I want to talk a little bit on the software project management side of things to explain what are the forces that are making that more difficult to work through. So let's talk about a given average normal software project. So at the beginning of a project, usually the effort is low because nobody is working on it. Some business stakeholder says we need to do an X, they're able to get a budget, and then they start taking people and forming a team, and that team starts working, and there's some original date or target for trying to get that thing done. And over time, it's a, work. Somebody says, we're not going to meet the deadline. Okay, here's 3 more developers. Work. Like, we're still not going to hit that deadline. Okay, here's 3 more developers. And then you kind of blow past that original date. And then after doing that enough, where enough functionality kind of sort of works well enough that somebody says, usually for political reasons, a manager will say, we're done. And most of the developers are like, what are you talking about? The system is still buggy as hell. We haven't implemented half of the functionality we promised our users, and the code's a mess. But it's called a success, sort of from a management perspective. And then the project is moved into maintenance mode, where when you think about maintenance, what's different about maintenance? Well, a lot of times the core development team that built the thing in the first place is moved to yet another very important project that is behind time. And other developers are brought in without any real significant onboarding or training. Say, here, maintain this. You say, okay, well, what does that mean? Well, we need you to build this feature. Okay, I'm building a feature. I need you to fix this bug. Okay, fix that bug. The difference between maintenance programming versus development programming is that maintenance means that the system is actually live. Users are using it. You can't just, erase the database and start from scratch. There's usually a lot more code. There's a lot more servers and moving parts to deal with. If anything, maintenance is actually a much harder activity to do well than programming the thing in the first place. So, taking the most skilled people and saying, oh, no, you don't do maintenance programming. You're there to do the software design and architecture, the important stuff. We'll leave the maintenance programming to the more junior folks. And unsurprisingly, those junior folks doing the harder activity, coming to something fairly messy to begin with, end up making it gradually messier over time, and it just becomes a longer and longer slog. Everything is harder. Every change that we make, we get bug regressions and things like that, and then more and more maintenance programmers are put onto it until things are going so terrible that somebody senior is brought in to sort out the mess. And then that senior person, usually an architect type title, will look across everything and say, you know what? It's a lost cause. It would be faster to write the thing from scratch rather than to add the functionality on top of this existing mess. And And my guess is that some of you that are currently on this presentation are in the midst of a rewrite project, because they're big, important projects and there's lots of functionality to do. And I got to tell you, rewrites are difficult to the point that they almost never succeed. And part of that is it's a management reason. It's not technical reasons, but a lot of the creation of the mess in the first place was due to management/technical mismanagement reasons. Rewrites, they're partially our fault because we're the ones that tell the business stakeholders, yeah, it'll be faster to rewrite it. So let me tell you, why do rewrites go so wrong so frequently? So some of you might have heard about this concept in software. It's called the iron triangle between time, resources, and scope. So essentially it says for a given amount of time, there is a given amount of scope that is able to be done by a certain number of resources. And no, it isn't good to talk about human beings as resources, but that's where the literature is coming from. Now, essentially what it's saying is physics. You can't have a free lunch. So if you look back and say, all right, this project, how long have we been slogging away at it? Well, if the code base is 7 years old, 10 years old, okay, so you've had however many, a dozen people working on this thing for over 10 years. And now someone says, okay, it'll be faster to write it from scratch than make this change. Do you really think for the same scope, all right? So the scope that took 10 people 10 years to do, that you're going to be able to do that same scope in a year with the same 10 people, even really good 10 people? I got to tell you, physics is not on your side at that point. And then you get into whole mythical man-month territory where the business says, all right, well, how about 20 people? How about 30 people? And again, there's a certain element of time you just can't sort of break the relativity and go faster than the speed of light. So invariably what happens is in a rewrite, and I'm sorry if I'm describing the exact project that you're on, but it happens all the time. In the first 20 to 30% of a rewrite, everybody's like, okay, we're going to do this right. We're going to do DDD, we're going to do BDD, we're going to do TDD, we're going to do all of the Ds. It's just going to be Ds everywhere. And then, we're cleaning, we're refactoring, we're, event servicing and everything. Somewhere around the 30% mark of the original time that was scheduled for this rewrite, there's this sort of sinking suspicion of saying, we're not going to make it. But there's just too much to do, right? We've barely scratched the surface of the functionality of the old system. And that's when the developers are like, okay, well, screw it. Quick and dirty. Just feature, go, go, go. Let's get some more developers in here, without realizing that the whole reason of doing the rewrite in the first place was to replace the old mess. Not to create a new mess, but, replace the old mess with something better, cleaner, long-term sustainable. Now, part of the question is, well, why don't we get more time? The reason is that essentially a rewrite is kind of a contract with the devil, where the business here is kind of saying, look, I'm willing to not touch the legacy code base, not anything but like critical bug fixes. Yeah, you got to give me those. But I'm going to give up no more feature development on the old thing, no nothing else. I'm willing to freeze that scope for you so that you can rewrite it. And you got to understand, this is a cost to the business because they're not moving with the market. There's only so long that they're going to be willing to freeze the scope. You're going to get a year and a half tops as an extension where they're saying, look, this is really painful. Our competitors have released some really important stuff and we're hurting in the market. The salespeople are screaming, you got to get this done. So, but like I said before, it's physics. You can't replace 10 years of development effort with a year and a half, 2 years. So essentially what happens is at some point you've created enough functionality that it is somehow worthwhile to ship it. But the problem is that none of the technical folks thought about, well, if we didn't implement all of the scope of the old system, then we can't shut it off. Essentially, we need to ship the new system and to run it side by side the old system. And essentially, we need to integrate between the old system and the new system, because there's a bunch of data in the old system that we need in the new system. There's a bunch of data that we're now collecting in the new system that needs to go to the old system. And now we need to do the sort of two-way data integration thing between two code bases that neither of them was designed to do this integration. And it's just becomes this supernova of coupling. It's just this totally awful death march at that point, where the idea of it's going to be clean and good and pristine at this time, everybody's forgotten about that. People are sleeping under their desks trying to fix these bugs and data quality issues. And at the end of this, we're at this big black hole of coupling. Just so much awful code, so much data duplication and inconsistency. And whatever consultants were there are saying, okay, I'm going to call that mission accomplished. Good luck. And they're just out of there. And at that point, if you thought that this is what your system looked like at the beginning of starting the rewrite project, at the end, with all of the other things around it, you're looking at something like this. It's just wires going everywhere, hacks on top of hacks, and databases calling each other directly, and it just becomes such a god-awful mess. So, to be honest, it didn't take you 2 years to get into your current mess. It's just not realistic to expect that you're going to be able to get out of your current mess in 2 years. It requires a much more fundamental shift, not only on the software side, but also on the management side. And to the software architect saying, okay, well, what we need to do is we need to have a 2B architecture of where everything's going to be and, work towards that plan. I got to tell you, these diagrams, I've seen them for decades, that like not even 10% of that materializes before it becomes hopelessly out of date. You can't plan your way to these problems. It requires truly long-term thinking, where long-term in the sense of planting a seedling today so that 20 years from now there is a tree. We're talking about multi-decade thinking and planning and operating horizons, nurturing healthy practices from the beginning, from the bottom up, gradually, organically transforming things. But it is a decades-long thing. Yeah, the short-term level you need to execute well, but so it's not overly pessimistic. I want to give you some of the practices for what this means. So first of all, mentally, anytime you hear the term project, try to replace that with the concept of product. All right? Project is a model for organizing a defined scope of work. Software, successful software, is not defined in scope. Once a piece of software is successful, the scope essentially balloons. It's add this other feature, now do this other thing, now we're getting more users, now integrate this other system. It's not a project. There's no done state for it. The better model to think of is a product, all right? So product, think something like iPhone. Think Toyota Prius. When a company like Apple or Toyota is launching a product, their baseline assumption, their thinking is, ideally, we want this thing to live forever. It's not that now it's going into maintenance mode, now it's going to this thing. No. As a product, we want to continue investing in this thing over the next several decades. So instead of thinking of it as a done state, think of it as a long-term product investment. And part of that means, as we've mentioned in the Agile spaces, delivering value iteratively, evolve it gradually over time, start with minimum viable products and gradually expand on those, and then integrate new technology, and then rebuild that, and then new camera, and then LiDAR, and all of these other things. But as a product, Think of it that way rather than projects. So that requires management and business stakeholders thinking about things differently. I want to now get back to what us on the software side can start to do differently. Part of this has to do with getting better requirements. A lot of times, developers or technical folks, we tend to assume that the requirements that we get are the right requirements. So the better mental model to use when engaging in an interaction between IT folks like us and our business stakeholders is that when they present us requirements, we interpret those as a workaround. A lot of times, what they're doing is they're presenting the solution rather than the actual requirement. So they'll tell you, okay, I need you to create me a screen here where I can sort by this column and do all this type of thing, and then click from that into this other thing. And we're diligently writing those things down and creating user stories and whatever. Those are workarounds. You need to be able to articulate the why for each requirement. Why do they need this? What job does this help them do? What does this relate to the other thing? This comes back to the use case view of software architecture that I was talking about before. So first of all, understand that business analysis is its own practice. You don't just record things that your business stakeholders and users are asking for. There is analysis and interaction. Part of it says, what if we did it this other way? Why wouldn't that work? What if we did this other thing? How is that better? What other needs does that serve? Going back and forth until you're able to articulate the main why of what they're asking for. To be able to say, all right, so ultimately you want, something to be better or cheaper or faster. Usually, most requirements can be put into one of those three buckets or more. It's a better this way, cheaper this way, faster this way type of thing. So when you're able to get that, then you now have an idea of what the real requirement might actually be. Doesn't mean that it's a requirement yet. You need to know how much it'll cost. This is where estimation comes in. Quick note, estimates aren't promises. So part of the reason why we get into trouble, we're not good at doing estimates. Another thing to note down, how do you give a good estimate? There's a structure to it. First of all, given a well-formed team of a certain size. Well-formed means not a random group of people that I just threw together yesterday, right? Well-formed means that the team dynamics have already been sorted out and that the team has the needed knowledge and skills required for that project. So saying, oh, I've got 10 .NET developers. Well, that's great, but this is a Python machine learning project. That's not a well-formed team of a size 10. So there's the teaminess of it. There's the knowledge and skill size of it. Another criteria, that group of people is not working on anything else. Any estimate that I give is based on ultimately their capacity. So if they're working on other things, then any estimate is out of the water. So assuming those criteria, then the estimate is I'm a certain degrees confident that it will take within a certain span of time. So that might be I'm 80% confident it'll take between 3 to 6 months. All right. Once you have those estimates, that starts the conversation around costs and discussions where you say that's how much it'll cost in terms of the estimate. Business stakeholders might say, I don't know, too broad a range. Then at an architecture level, we can start doing proof of concept, give me a day, give me a week, and we can start to try to provide better estimates that are more accurate, a better range. Sometimes the result of all of these things is we need to loop a bunch of times to be able to come to any type of confidence. The end result of all of this is hopefully an estimate that the business says, yes, good, I like it, that feature is understood, the why of it is good, the estimate is accepted, let's go. So while at that point you have a requirement, the assumption is often, oh crap, you're going to have it done by that end date. That's where project management needs to come in and make it clear that no, the fact that it's going to take 6 months doesn't mean 6 months from now. it's 6 months from the last unit of work that we've already committed to. So after going through all of that, management reprioritizing requirements back and forth, we can get new dates for things and hopefully get those things accepted to the point where ultimately we've got a schedule. And to be clear, if you think any of this is easy, it isn't. Once you put things on the timeline and you start sharing those with other stakeholders, then all of a sudden people are going to say, oh no, but we've already committed to present this thing at a conference to, really big important customer by the end of the year. All of that gets reprioritized. So that's on the product project management side of things. I want to say some final words on the technical side of things because I know developers create so much unnecessary complexity. Just a few more minutes. First of all, about scale. Everybody tries to do all sorts of fancy stuff with scalability. The event sourcing, the CQRS, the serverless, the NoSQL databases. If you're not at Amazon scale, Twitter scale, whatever, I want to let you know, Moore's Law is still alive and kicking. You can scale up a lot. So just recently, I looked at the AWS EC2 type of table to see what is the biggest, beefiest type of machine you can get. And this was, maybe a month ago. You could get a machine with 448 CPUs and 6 terabytes of memory, right? This is a beast. And if you sign up for a reserved instance for a 3-year term, that's going to cost you $13,000 a month, which is not really that expensive when you think of it. So compared to developer time, and for a lot of data sets, I got to tell you, 6 terabytes of memory, if you can hold all of your data in memory, all of your performance problems are gone. So try to take a look at what can be done via scale up and just throwing raw performance hardware at the thing before starting to get fancy with your software patterns and whatever. Life can be so much better. And just, one last thing, if you start thinking really long-term beyond these types of things, really long-term, just for reference, this tree in the picture, this bonsai tree, is over 1,000 years old. It's still alive and kicking. So the equivalent thinking for that in our space, where I said think about products instead of projects, for us in this field, it's a small field. It's the relationships along the way. The folks that you're working with today, you're going to see them again 10 years later, 20 years later. Be kind to each other. Be good. Be considerate. That's the stuff that ultimately matters long term. For those of you that are interested in learning more about this kind of stuff, there's a whole course that's available. It's available at that URL, go.particular.net/EPAM-22. And I know there's so much more that you want to get into and questions that you might want to have, but I do have to wrap up. Thanks again for coming to my session. I'm at Udi Dahan on Twitter, so long as Twitter is still around, and working at Particular Software. Looking forward to hear from you. Thank you very much.
Thank you very much, Udi. Unfortunately, we have no time left for the questions, but please do not worry. Leave your question in the chat or on the page, on the talk page, on the community page, and Udi will get back with the answers. So to sum up, I would like to thank you, Udi, for the insightful presentation. Thank you very much for being with us today and sharing your knowledge and experience. Thank you very much, everyone, for joining. Please stay with us. The topic of the next talk will be panel discussion, Agile and Engineering Excellence, why you can do one without the other. Thank you very much.